So today we are going to prove a property about a gamma function. So gamma function is by definition defined by this integral x to the alpha minus 1 times e to the minus x dx from 0 to infinity. Now we have to prove that gamma of alpha plus 1 is alpha times gamma of alpha. So first of all we start with the left hand side. So we'll say gamma of alpha plus 1. So this is equal to 0 to infinity x to the alpha plus 1 minus 1 e to the minus x dx. This is equal to 0 to infinity x to the alpha e to the minus x dx. Now here we can do integration by parts. We can say u is equal to x to the alpha, and our du will be alpha x alpha minus 1 dx, and we can say dv is equal to e to the minus x dx, which means our v is equal to minus e to the minus x. So now what is the formula for integration by parts? Integration by parts, we have u dv. This is equal to u times v minus integral of v du. Okay, so this is then equal to u is x to the alpha, v is minus e to the minus x minus v is again minus e to the minus x, and du is what? Du is alpha I can take outside, x to the alpha minus 1 dx. Okay, so then I can get minus x to the alpha e to the minus x, plus I can take this minus and this minus, and I can say x alpha minus 1 e to the minus x dx. Okay, now let's put the limits 0 to infinity here. So 0 to infinity. So then if I put 0, then this goes to 0. If I put infinity, then this makes it 0. So if I put the limits, this whole thing goes away and I have a 0 here. So plus alpha 0 to infinity x alpha minus 1 e to the minus x dx. Now this guy is exactly the definition of our gamma function. So then this is equal to alpha times gamma of alpha. So then what we have proved here is that is equal to alpha times. Now okay, so what is gamma of 1? This is equal to 0 to infinity x to the power of 1 minus 1 e to the minus x dx, which is equal to 0 to infinity e to the minus x dx, which is equal to e to the minus x divided by minus 1, 0 to infinity, and which is equal to 1. Okay, now since we have the property alpha plus 1, this is equal to alpha times gamma of alpha, we can use gamma of 1 is equal to 1 and find the gamma function for any integer, positive integer. So what should be gamma of 2? This is equal to 1 times gamma of 1. This is equal to 1. What should be gamma of 3? Which is equal to 2 times gamma of 2, which is equal to 2. What should be gamma of 4? Should be 3 times gamma of 3, which should be equal to 3 times 2, times 2, which is equal to 6. So you can appreciate that if I extend it to any integer here, so this should be equal to n minus 1 factorial. So this is a property which would be very useful if you can memorize it. If you cannot memorize it, just know that if you know just this relationship about the gamma function, it is immensely useful. So hope